Hello, in this video, I'm going to walk you through a notebook that visualizes labeled images from the CGIAR Root Volume Estimation Challenge. The goal here is to group together related images so that the patterns and the segmentation masks become much easier to spot. Let's dive in. We define the path to our dataset and load the metadata about our training images. This metadata is crucial as it tells us how the images are organized into different groups or folders, which is key to our later grouping and visualization. The plot of the first image points out an interesting issue. The images are very short, which makes it hard to see all the details. To overcome this, the idea is to group images that belong together with the same folder name and side. By doing so, we can see how the images and the masks that label regions of interest change across different depths, making the patterns much more evident. This is where things get really interesting. A series of helper functions are defined to streamline the visualization process. Grouping images and labels. This function helps us collect all the image files and their corresponding label files for a given group. This grouping makes it easier to process and display images that belong together. Generating colors. We need to generate unique colors for each object in the image. Parsing the label files. The labels for the images are stored in files where the coordinates of polygons, which represent the segmentation masks, are given in a normalized format. Drawing the masks. With the coordinates ready, another function takes care of drawing the polygon masks onto the images. Resizing images. Since the images could vary in size, there's also a function to resize them while keeping the aspect ratio intact. This uniformity is important when we stack images together for a combined view. Processing and displaying groups. Finally, there's a function that brings everything together. It matches images with their labels, applies the mask drawing, resizes them to a consistent width, and then stacks them vertically. The result is a single, tall image that clearly shows all the grouped images with their respective masks. After setting up these helper functions, the notebook loops over each unique group in our training data. For every group, and for both left and right sides of the image, the script retrieves the corresponding image and label files, draws the masks onto the images, resizes and stacks the images together, and displays the final grouped image. Now we can see the final results in a series of stacked images, each representing a labeled group. The bright outlines highlight the root sections in each frame, making it easy to observe how the labeled regions align across different depths. This process not only makes the labeled regions more visible, but also highlights the consistency of labeling across images in the same group. You can clearly see how the patterns evolve, and any inconsistencies become immediately apparent. To sum up, this notebook is a good example for anyone working in this competition. Thank you for watching. If you have any questions or need further clarification, feel free to leave a comment below. Happy coding, and see you in the next video.